All right, here we go, part two on the 1.7 um, notes here. It says sketch the graph and then label the vertex. So make sure we do all these pieces asked of us. Label the vertex, the x-intercepts, the y-intercepts, and the line of symmetry. So please don't skip out on any of those pieces. We got to get them all in there. So here we go. Now again, there's two methods we had for finding the vertex. One was negative b over 2a, so negative, negative 5, so positive 5 over 2 times 1, that's our a value. So we'd end up with 5 halves, which is 2.5. We also could solve by factoring, and so if we'd factored, we'd have y equals, let's see, x and x. What multiplies to give you 6, but adds to give you negative 5, it's going to be negative 2 and negative 3, giving us roots of 2 and 3. All right. So our axis of symmetry, again, it goes right through the vertex. And either way you go about finding it, the x value of the vertex is at 2.5. That's our x value. Now, how do we actually find out what the y value is? And so, sorry, again, the roots were, the roots would be where y is equal to 0. And so 0 equals x minus 2 and x minus 3, meaning the roots were at 2 and 3. Now, as far as finding the actual vertex itself, so we got our x value. How do we know where our y value is at? We're going to plug it back into the equation. And it looks like in its factored form will maybe be a little bit easier here. So we have y equals 2.5 minus 2 times 2.5 minus 3. That's y equals 0.5 times negative 0.5. We should actually get the zeros in there, 0.5, 0, and negative 0.5 here. And that will give us that y is equal to negative 2.5, or negative 0.25. There's our vertex. So 2.5 comma negative 0.25. And I kind of ran out of space there, so let me just rewrite all that a little bit clearer. Our vertex is at 2.5 comma negative 0.25. There's our vertex. All right, right around there. Okay. So we found our vertex. Our x-intercepts, we found those already and graphed them. Just to be very explicit about it, they are at 3, 0, and 2, 0. Again, that vertex was at 2.5 and negative 0.25. And now we need the line of symmetry, which we said was x equals 2.5. So it looks like we've got all of our pieces. Oh no, we need to find the y-intercept. And where do you have a y-intercept? Well, you have a y-intercept where x is equal to 0. So if we either want to plug it into the factored form, but for that it's probably going to be easier to plug it back into our standard form, because 0 squared minus 5 times 0 plus 6 means that we're going to have a y-intercept at 0, 6. So 3, 4, 5, 6. There's our y-intercept, 0, 6. And sketch it on out. Should be curved here at the bottom. My sketch isn't the prettiest one, but there's a rough sketch of that parabola. All right, next we've got y equals 2x squared plus 8x minus 2. And so let's go with our negative b over 2a this time. So negative 8 over 2 times 2 means our axis of symmetry is at negative 2. Because it's 8 divided by 4 made negative 2. So we'll sketch that axis of symmetry in. X equals negative 2. And to find our vertex, we're going to plug that back in. So our vertex is at negative 2, comma. Well, negative 2 squared is 4, and 4 times 2 is 8. So y is going to be equal to 8. And 8 times negative 2 will be minus 16. And minus 2. So 8 minus 16 is negative 8. And negative 8 minus 2 is negative 10. So counting all the way down to the bottom here. There's our vertex at negative 2, 10. Now we have our y-intercept. Our y-intercept is going to be at 0, negative 2. Because again, you have a y-intercept where your x value is 0. So 0 plus 0 minus 2. And just to help us graph, it's not required, but remember this is a axis of symmetry, so this point gets reflected over. And now our x-intercepts are going to be right around here and here, and we could find those. To do that, you would use the quadratic formula. So negative x is going to be equal to negative b, so negative 8 over 2 times a, 2 there, plus or minus the square root of b squared, so 64, minus 4 times a, which is 2, times c, which is negative 2, also over 2 times a. Alright, and that gives us, I'm running a little bit short on space, but that's going to give us negative 2 plus or minus. Now 64 minus 4 times 2 is 8, times 2 is 16, so 64, and then plus, because minus a negative. 64 plus 16 is 80, and 80 will reduce down, let's see, 4 times 20, which is 4 times 5. So the square root of 4 times 4 times 5. This means a 2 comes out and another 2 comes out, so plus or minus 4, not 2. 4 root 5 over 4. 4 root 5 over 4 is really just the square root of 5. And there's our x-intercepts. Now if you were to look at these, notice how the axis of symmetry is where we're starting from, negative 2, and then we're subtracting and adding the same number. That's part of why we have this axis of symmetry. And think about this as the square root of 5 is in between two whole numbers, and it's in between 2 and 3 because the square root of 4 is equal to 2, and that's less than the square root of 5. But it's not quite as big as the square root of 9, which is 3. And so we're going to start from axis of symmetry, go a little bit more than 2, and a little bit more than 2 to both positive and negative, adding, subtracting. And now we can graph our parabola. And again, it should be a little more curved than what I've got right here. Let's go ahead and quickly jump back in and make sure we are very explicit about our various points. Down here at the very bottom, we had our, or actually this one right here, this is our vertex. 2 and 3 are our x-intercepts. 0, 6 is our y-intercept. and x equals 2.5 is our axis of symmetry. Over here, x equals -2 is our axis of symmetry. 0, -2 is our y-intercept. This point right here, this root, that's going to be, actually let's go ahead and do it in purple just to not confuse it. That one's going to be at -2 plus root 5 comma 0. That's our x-intercept. Over here, this one is at -2 minus square root of 5 comma 0, and that's our other x-intercept. And then down here at the bottom at -2, -10, this is our vertex. All right, hope that helps.